Welcome to this lesson, Chapter 3, Mathematics Form 2, Indices and Logarithms. Today we want to look at this topic. Now, we have learned these things in Form 1 where we write the factors of a number. For example, if I have 64 equal to 2 times 2 times 2 times 2. That is 8 times 2 times 2, right? But I can, because this is 2 repeating itself, I can write this as 2 raised to power 1, 2, 3, 4, 5, 6 to power 6. So this one is what we call the index. And the index in the plural, they are called indices. Indices. Right? So the power and the index is the same thing. So we say that 2 is raised to power 6. 2 is raised to power what? Power 6. So the index of 2 here is 6, and it is called the power. Why is it called the power? 2 raised to power 6, it means we multiply 2 by itself 6 times. 1, 2, 3, 4, 5, 6. That's why we call it the power. Now we read the 6 raised to power 6 as 2 raised to power 6. 2, 6, it means 2 raised to power 6. So this 6 is the power. The power is also called index. The plural of index is indices. That's why we have the topic indices and logarithms. So whenever you see index, we are talking about the power of a number. So 2 raised to power 4. 4 raised to power 2. The answer is 16. The answer here is 16. So this is the power. This is the power of this number. Now 2 raised to power 6. This number here is called the power. We have said that. Now what about this number 2? 2 is the base. So if I have 4 raised to power 3, 3 is the power or the index, 4 is the base. Those are the major important things that you must master. That 4 is the base, 3 is the power. Very important. So what is a power? A power or index is the number of times the base is multiplied by itself. So if I have 5 raised to power 3, I am saying that this base is multiplied by itself how many times? 3 times. Therefore, the power, the index, tells us how many times the base has multiplied by itself. 4 raised to power 6, the power here tells me that this 4 is multiplying by itself 60 times. 4 times 4 times 4 times 4 times 4 times 4, 60 times. That is what it means. When I have a 2 raised to power 3, it is the same that 2 times 2 times 2. That is the same thing, and the answer is 8. Right? So that's what it means. A times A times A times A. It means 1, 2, 3, 4. It means A raised to power 4. This is the base, this is the power. Now the next thing we want to look at is the laws of indices. Laws of indices. Indices has got laws which we must master, understand, for us to pass in mathematics. Laws of indices. Multiplication or division of numbers with the same base. You must mark that, same base. makes the indices of these numbers to be operated using the following rules. So there are rules we are going to learn when we multiply numbers which has got a certain power or index and they have the same base. So the rules are as follows. So we start with multiplication. When we multiply numbers which have the same basis, different index, what happens? So I will start with an example. For example, if I have a raised to power 4 times a raised to power 3, the major thing is that the base is the same. Now you know what is the base and what is the power, the index. Because the bases are the same and we are multiplying these two numbers, we add the index. That is the row. If the bases are the same, we add the powers. We add the power. So, for example, this one, a raised to power 4 times a raised to power 3, the answer is a. You take one base, because the bases are the same, you take 1. And then what did you do with the powers? You added them, 4 plus 3. So the answer is a raised to power 7, and that is the row number 1. That in multiplication, if the bases are the same, you add the power and then you pick one base and then write your answer. Let me take, for example, 4 raised to power 2 times 4 raised to power 3. Bases are the same. The power here is 2, the power here is, or the index here is 2, the index here is 3. So you pick one base, that is 4, and then you add the powers. So 2 plus 3 is 5. That's rule number 1. Remember, this rule only applies when the bases are the same. If the bases are not the same, don't try that. So generally, a raised to power m times a raised to power n, the answer, you pick a, the base, and then m, the power m, plus n, and that is rule number 1. I have done an example, so maybe I will do another one. 3 raised to power 4 times 3 raised to power 2, or 3. So the answer, the base is the same, 3. 4 plus 3, the answer is 7, and that is the answer, because the bases are the same. Number 2, division. We know very well that a raised to power 5 divided by a raised to power 3, this is the same as a, this 5 times a times a times a 5 times 2, 3, 4, 5 divided by a times a times a, because this is a, so this a cancels this one cancels this, and this one cancels here. The answer is a square 2a, so that is the answer. So what has happened? It seems that when the bases are the same and we are dividing, we subtract the powers. So this one is the same as a, you pick one a, and then 5 minus 3. What is the answer? A raised to power 2. Rule number 2. 3 raised to power 8 divided by 3 raised to power 3. Bases are the same. So what it means is that you take one base, 3, and then you subtract the indices, the powers. 8 minus 3. The answer is 5. So in general, a raised to power m divided by a raised to power n, the answer is you pick a and then m minus n, and that is rule number 2. This is a, not 9. Rule number 3, the powers. So if I have a raised to power 2 and then raised to power 3, both of them are the powers. These are indexes. So what do? You simply multiply the powers. So the answer here is a raised to power 6, and that is the answer. So if I have 2 raised to power 4 and then raised to power 2, the answer is this power times this power, which is 2 raised to power 8. I have some few examples here. 4 divided by 4 raised to power 6 divided by 4 raised to power 2 times 4 raised to power 9. So this one, the bases are the same, the rules apply. So 4 is the base, the base is the same, and then now 6 here, division means subtraction, so we subtracted 2, the power here, and then this has been multiplied and the power is 9, so we plus, for this multiplication we plus 9, and this one will give us 4 raised to power 13 raised to power 13. 8 raised to power 5 times 8 raised to 8. This 8 has not been raised to any power. N number, which is just a number not raised to n number, it is simply raised to power 1. So this one is 8, 5 plus 1. There is 1 here which is not there, which is not visible. So 3 plus 1 plus 2. And the answer is 8 to power 8. 2 raised to power 8 raised to power 3. You multiply the powers. That is 2 raised to power 24. That's how the rules apply. Zero index. Zero index, these are the numbers with 0 power, with the power of 0. For example, let us consider 5 raised to power 4 divided by 5 raised to power 4. In the division, we have said we subtract the power. So this is, the base is 5. 4 minus 4, the answer is 0. So this is 5 raised to power 0. And this is what we call the zero index. The power is 0. So we want to know, when a number is raised to 0, when a number has a power of 0, what is the answer? So any number, it doesn't matter which number it is, any number raised to power 0, any number raised to power 0 is 1. Any number raised to power 0, the answer is 1. So 5 raised to power 0, the answer is 1. 3 raised to power 0, the answer is 1. 1000 raised to power 0, the answer is 1. Any number raised to power 0, the answer is always 1. So generally, a raised to power 0, the answer is 1, where a equal to numbers 1, 2, 3, 4 to 1, to every number you may think of. So any number raised to power 0, the answer is A. You can even try using a calculator and you will find out that 500 raised by 0. What is the answer? 1. What? 1. Positive indices. We want to consider this example. If we have AB, which is a number like 20 or 40 or 50, a number squared, for example, what does it mean? We know if it is it means AB times AB, right? Yes. So AB squared, it means AB times AB. What does it mean? It means A times A, which is A square, times B square, right? And this one is equal to A square, B square. So it means that if we have a fraction, for example, suppose we have this fraction here, 3 over 4 raised to power 3. What does that mean? It means that 3 is raised to power 3 divided by 4 raised to power 3. That is it. So in general, AB raised to power n, the answer is A. You raise this power n is raised to both of these numbers. That's A, N, B, N. A, N, B, N. If we have A divided by B raised to power n, the answer is going to be A raised to power n divided by B raised to power n. That's what it means. Quick examples. 2 examples. 2A raised to power 4. What does that mean? It means 2 raised to power 4, A raised to power 4. And the answer is 16A4. 3y square raised to power 4. It means 3 raised to power 4, y raised to power 2 times 4, which is 8. And the answer is 81, y raised to power 8. That's that. Another good example is 2a raised to power 5 times 3a raised to power 4. That's another example we can use. This is a number and this is a number, right? So 2 times 3. Nothing changes. We have the answer 6. This is A and this is A. The bases are the same. Power 5, power 4. So A, the power is the same, right? Now it is multiplication. What do we do with the powers? We add 5 plus 4, 9. So the answer is 6A9. Simplify the following. 24A6 times 5A3 divided by 8A7. So how do you simplify that? This is a number and this is a number. 8 is divisible by 8. So 24A6 times 5A3 divided by 8A7. We start here once. Here was 3A's, right? Now we have 7A. Now even if we, okay, this one, this times this, we can even go direct. 5 times 3, that is 15. 6, this is A, 6A, so the bases are the same, A. And then multiplication, we add the bases. 6 plus 3, 9. Divided by A raised to power 7, right? Now we have A. We are dividing. When we divide the bases are the same, what do? We subtract the power. So the answer is 15A. 9 minus this, the answer is 2. 15A2. 4 divided by x raised to power 2. That simply means 4 raised to power 2, x raised to power 2. That is 16 divided by x squared, and that is the final answer. So far we have been dealing with positive integers. We want now to look at the negative indices. We were dealing with negative, we have dealt with positive indices or index. Now we want to look at the negative index. Well, how does the index negative comes in negative? For example, if I have 5 raised to power 3 and then divided by 5 raised to power 5, what is that? The power is 5, right? And then when I will do what? 5, the power when we divide the power, the rows remain the same. We are dividing, so we are going to subtract 3 minus 5. What is the answer? Negative 2. So you see now the power here, the index is negative. So that's why we call them negative index or indices. So that is the negative index. So a raised to power 3 minus a raised to power 6, the answer is, or divided by, not minus, the answer is a raised to power negative 3. So 5 raised to power negative 2 is exactly the same as this. 1 over 5 raised to power 2. Did you see what I did? 5 raised to power negative 2 is exactly the same as 1 divided by, now when you put 1 above as the numerator, the denominator becomes positive. It was negative, it becomes positive, and this one and this one are the same. I have a raised to power negative 3. So if I'm asked you to write this a raised to power negative as a positive index, then what I will do, I will have 1 divided by a, instead of negative now, because I have getting, I'm looking for the reciprocal, it becomes positive, right? Those are the things you need to master. The next thing, so it means that generally if I have a raised to power negative n, then the power here is negative. So to turn this one into positive, to change this one into positive, it means it is a positive n. But you must always put 1 over. So it is 1 over a raised to power n. That one is positive. So examples on negative, negative indices. For example, we have 2, example A, 2 to raise to power negative 3 times 2 raised to power negative 2. What is the answer there? The bases are the same, so you write it 2. We are multiplying these two bases, right? We are multiplying these two of them, so the powers, what do? We add. That is negative 3 plus negative 2. But you should also remember that a negative times a positive in form 1, the answer is negative. So the answer is 2 raised to power negative 5. So 2 raised to power negative 5 is exactly equal to 1 over 2 raised to power 5. But you are right up to that point. So this, I'm just showing you what I have said here. So this is the correct answer. Another example B is A raised to power negative 4 divided by A raised to power negative 2. This is a division. The row says when the bases are the same, the index, we do what? We subtract. So A negative 4 minus 2. We are subtracting, but what we are subtracting is a negative number. So negative times a negative is positive. So we will have A negative 4 plus 2. And the answer is A raised to power negative 2. You must understand what we call integers. Form 1. This one also needs integers very, very much. So you can be, another thing you can express the following numbers. Express the following numbers with positive indices, with the positive indices. So you are giving the numbers as A 5 raised to power negative 3. I have told you that 5 raised to power negative 3 is exactly the same as 1 over 5 raised to power 3. So this one is positive and this one is negative, right? B, if I give you A over B raised to power negative 3, what does it mean? This is simply 1 over A over B raised to power what? Positive 3. But the simple fraction you did, this is the same as 1 divided by A over B raised to power 3. So what does that mean? So this means that 1 divided by times now times B over 3 raised to power over A raised to power 3. So the answer here is B over A raised to power 3, the reciprocal. This is the same as B 3 over A 3. This one is because it is there, right? What I have done here is what we learned in Form 1, the fraction, when you divide the fraction. So this one divided by this fraction, the P comes up, A comes down. That's why we have here AB and here it is BA. Form 1 fractions. Another number maybe I will give you is 2A raised to power negative 5. You write this number as a positive. So it is simple. This one simply means 1 over 2A. No, 2 is not affected, sorry. This is 2 A negative 5. This is the only number which is negative. Therefore, it is 2 1 over A raised to power 5. So 2 times this is the same as 2 over A raised to power 5, and that is how you write it positive. A raised to power 5. Yeah, next one we are looking at fractional indices, the fractions of indices. So the fractions also is the same. The rules apply, the laws apply as the same. For example, if I have 5 raised to power a half plus, times 5 raised to power a half. The power is a fraction. The power is a fraction. What does the rule say? The bases are the same, so it is 5. A half plus a half is 1. Right? So it means that the 5 raised to power half times 5 raised to power half, the answer is 5 raised to power 1. So a number raised to power 1 is the same as that number. Another thing you want to look at is 25 raised to power a half. So I want to show you that a number raised to power half simply means if it is a half, it is the square root of that number. If a number is raised to power a half, it simply means the square root of that number. So 25 raised to power half is the same as this, which is equal to 5. So 25 raised to power half, the answer is 5. 100 raised to power half simply means square root of 100, and the answer is 10. Very good. 16 raised to power half simply means 4. Why? 16 raised to power half equal to the square root of 16, and the answer is 4. 1 over, A raised to power 1 over 3 times a raised to by 1 over 3 times a raised to 1 over 3. This is okay, let me even call it 9. So 9 raised to power third times 9 raised to power, the base is the same, so the answer is 9. And then you add a third, because it is multiplication, a third plus a third plus a third. What is that? 1. Right? So 9 raised to power a third. Okay, 9 raised to power. No, that one will not work. 27 raised to power third. 27 raised to power third simply means a third is the cube root of this number. And the answer is 3. So 27 raised to power a third, the answer is 3. It simply means the cube root of that number. So one thing I want you to know is that when a number is raised to power a fraction, you find the root of that fraction. If it is 16 raised to power 1 over 4, so you find the answer here is the same as the fourth root of 16. The fourth root of 16. And the fourth root of 16 is what? Is 2. The fourth root of 16 is 2. I don't know where that one has gotten into your head. Thank you. So if I have, for example, let me use this example here. 8 over 27 raised to power third. This one simply means, because this is the power, it means that this number is raised to power third and this number is raised to power third. This one is the same as 8 raised to power third divided by 27 raised to power third. Right? But a number which is raised to power third means the cube root. For this one is the cube root. So this one is equal to 2. This one equal to 3. And that is the answer. How to apply indices? Further examples on indices I've given here. So you will be asked to find the value of x in 81, x raised to power x equal to 243. So here they want to test whether you have understood the base. So here first find the base that can be used here and here in both cases. So 81 we know 3 goes there. So 3 goes here 4 times. So 3 raised to power 4 is 81. And then 3 is x. So x equal to 3 raised to power 5. Now when the bases are the same, you ignore them and then you find the value of x. So you equate the powers. So 4x equal to 5. Because now the bases are the same, you ignore them. So divide by 4, and you find the value of x is equal to 5 over 4, which is the same as 1 over 4. Part B. 25 raised to power 4x equal to 125. So you see 25, 125. There is a common base there. 5 is a common base. So 5 raised to power 2, 4x, because it's also a power, equal to 5 raised to power 3. 5 raised to power 3 is 125. Now the bases are the same. We ignore them and we equate the powers and to get the value of x. So 2 times 4x is 8x, which is equal to 3. The value divided by 8 divided by, so x equal to 3 over 8. So this is how we apply the indices there. I will give you another example here. See, 3 times 2 raised to power a plus 5 equal to 768. Equal to 768. So you see this, the power, this one is 3 raised to power 1, so it is not the same base, but it has been multiplied. This number, so what you do, you remove this number by dividing 3. Divided by 3. Both sides. So 2, we remain with 2a plus 5 equal to, if we go this one here once, here 256. So we have 256. Now 256 can be written in terms of base 2. So 2 raised to power a plus 5 equal to 2 raised to power 8. Now the bases are the same. Once the bases are the same, you ignore them and you equate the powers. So a plus 5 equal to 8. So a equal to 8 minus 5. This one you take to the other side and it becomes negative. So a equal to 3. A equal to 3. One more example, last one in this first subtopic is 1 over 8 raised to power n equal to 1024. Right? So this number can be written into base 2. So it is means that 1 over 2 raised to power 4 raised to power n equal to 10 raised, but we can write 10 into 24. We can write this number into base. So 1 over 2 raised to power 4n equal to 2 raised to power 10, because this is raised to power 10. But this one, you should know it means like this. It means that 2 raised to power negative 4, because this and this are the same, equal to 2 raised to power 10. Now the bases are the same. We ignore the bases, we use the powers. So this times is negative 4n equal to 10 divided by negative 4 divided by negative 4. So n equal to 2 here, 5, 2. So 5 over 2 n negative. So n, that is the value of, I was doing outside anyway. So this is how I have done it. Thank you. More examples. Solve for x. Now we have 4 raised to power 5x divided by 2 raised to power 3x into bracket raised to power 2 equal to 256. Now for the this is a division. The first thing we need to understand, we must make each of these numbers to the same base. The base must be the same first, so that we can be able to do it. And our smallest base here is 2. So we write all of the other numbers to base 2. So let me write this to base 2. 4 is the same as 2 raised to power 2. But there is 5. So 5x divided by 2. We can remove this bracket. We multiply, that is 6x equal to 2 raised to power 8. The next one is that this is 2 raised to power 10 divided by 2 power 6x equal to 8. As now you can see our bases, all of them are the same. If they are the same, this is a division. What do we say? If it is a division, now we ignore the bases. And what do we do with the powers, the indices? We subtract. So this means now 10, so 10x, sorry. This is 10x. So 10x, division means subtraction. 6x equal to 8. We ignore the bases. Now 10x minus 6x, the answer is 4x equal to 8. So divide by both sides by 4. Therefore x equal to 2. That is it. So let us solve for x for this sum. This is 2 times 3 raised to power x equal to 162. So the first thing, this number is a whole number 2. It is raised to power 1. Multiplied by 3 raised to power x and this one. So the first thing you do, you have to use your knowledge that we have to divide by 2 here so that we can remove these 2. Divide by 2, divide by 2. So this and this goes, This one goes here 8, 1. Therefore now we have 3x equal to 8, 1. Now we have removed these two there. Now the next one now is our base is 3, so this number can be written to base 3. That means 3x equal to 3 raised to power 4. So now the bases have become the same, so what do? We ignore them, and that means x equal to 4. That's what it means. Now we want to look at the second part of this topic, logarithms. Now what is a logarithm? We want to define a logarithm if a number y is expressed as a raised to power x. The index or the power x is called the logarithm of the number. Of the number y, where a is the base. A is what? The base, and this one is the power. So if a number y is expressed as a raised to power x, the index or the power, this power here is what is called the logarithm of a number. So if I have, for example, 2 raised to power 8, the logarithm here is 8, which is the power. This is the logarithm, and this one is the base. Similarly, we are saying here that the logarithm of 9 to base 3 is 2. What we are saying is that 3, this is the base, the power is 2, which is the logarithm, equal to 9. 3 raised to power 2 is 9. So the logarithm of 9, when the base is 3, is 2. The logarithm of 81, when the base is 3, the answer is 4. Meaning that 3 raised to power 4, the power, which is the logarithm, equal to 81. That's what it means. So what we have written here means like this. So this means this, what I've written, these two statements means, or is written in a short form. Is written in a short form as this, as follows. The logarithm of 9 to base 3 is 2. So it means that log, when the base is 3, right? The logarithm of 9, when the base is 3, the answer is what? Is 2. Also, the second statement, the logarithm of 81 to base 3 is 4. So log, when the base is 3, 81, the answer is 4. Yeah, log, this is the base, this is the answer, and this is the power. So I want to identify this one. We call this one as the power. This one is the answer, and this one is the base. So what do I mean? So if I can change this, I will say 3 to power 4. What is the answer? 81. Very good. Now log of base 3 of 9, the answer is 2. Now I can say log of base 10 over 1000. Log, when the base is 10, 1000, the answer is 3. What does it mean? It means that 10, the base, times the power, or raised to power 3, the answer is 1000. So this one means this. log to base 5 of 25 equal to 2. So log 25, when the base is 5, the answer is 2. This means that 5, which is the base, raised to power 2, the answer is 25. Right? Now this one, it has its own name, and we have the name for this one. This one is called logarithmic notation. This one is called logarithmic notation, and this one is called index notation. Index notation. So you will be asked, write 5 square equal to 25 as a logarithmic notation, or in a logarithmic notation. So this one means you introduce a log, the base is 5, the answer is 25, and the answer is the power is 2. So logarithm of 25 to base 5, the answer is 2. Now this one is called logarithmic. You can also be asked, change this into index form. How do you change this one into index form? The base is 5, the power is 2, the answer is 25. So index form of log 5 25 equal to 2. How do you write the index form of this? The base is 5, the power is 2, the answer is 25. So this one is called the index form, and this one is called the logarithmic form. So generally a raised to power m equal to n can be expressed, or can be written as, this is the base, log the base, which is a, and this is the power, and this is log of n equal to m. So this one is the general representation of this. We can represent this one in a logarithmic form as this. Write each of the following in index form. So we have in a logarithmic form, we want to write this one in index form. So I want you to understand that this log, the number below the log, is the base. This number here is the base. The answer is the power, right? The equal to, this is the power. I have explained up there. Therefore, this one, we just, the base is 2, the power is 3, the answer is 8. This one is log b. So b is the base, c is the power, and the a is the answer. This is a log to base 10, the base is 10, the power is x, the answer is 8. So I can ask you to write this one into logarithmic form. So what do? This one is the base, you just write log, right? Log, the base here is 2, this is log of 8. The answer here, the power is the answer, is equal to 3. So you come back to what we have done there. It is a simple start. I want also to give you this note that the logarithm to base 10 of 10, the answer is 1. The logarithm, the log of base 10, but actually we don't write base 10. The logarithms that are provided in our table are all of them to base 10. Look here, logarithm of numbers base 10. So n number, even in a calculator, if they have not written n 2 or 3 or 4 here, it means that log is log base 10. So our table and our calculators provide logarithms of numbers to base 10 only. So I wanted to say that log 100, the answer is 2. This means the base is 10. if I write log 1000, the answer is 3. There is 10 here that we don't usually write, so there is always 10. When you find a number written as log like this without 10, it means log 10. But if it is log 2 to base 2, it will be indicated. If it is log to base 3, it will be indicated, or it has to be indicated here. But if there is no anything here, it is always log to base 10. So log to base 10, 1000, the answer is 3, which is okay. It means 10 raised to power 3 is 1000. So you should know that. It is very important for you to know that. So we want to find logarithms from the mathematical table. You will find the logarithm of 28.5. This one is the same as log, like that. Find the log of that. So if it is a calculator, you will just place very fast. You will just use a calculator if it is a calculator and say that log 28.5. Log 28.5. And the answer is 1.4548. Very straight. But now we want to, how can we get this number, this answer for 1.4548 from the mathematical table? Our mathematical table does not have logarithms of numbers more than 10. So 10 and above, there is no logarithm for that. We have numbers from 1 to 9.999. Therefore, if you have 28.5, you need to write that number in standard form. So write this number in standard form as 2.85 times 10 raised to power 1. Right? Now, go to our logarithm table, find the log of 2.85 here. The logarithm of 2.85, 2 is here, 2.85, 0, 1, 2, 3, 4, 5 here. So the logarithm is 0. There is a 0. This one already is a 0 point. So 2.85 is 0.4548. 48. So the logarithm of this one is 0.4548, right? And the logarithm, now this is multiplication, we add. What is this one is the same as log to base 10, 10, the answer is 1, right? Because the power is 1. Therefore, we add this 1. So 1 plus 0.4548, the answer is 1.4548. And this is what we saw in our calculator. This is what we obtained in our calculator. So that's how we use the mathematical table. I want to give another example from the mathematical table. Find the log of 379. 379 is not available in our table, therefore write this number in standard form. This one is 1, 2, therefore it is 3.79 times 10 raised to power 2, right? Now this number is available in our mathematical table. Take your mathematical table, 3.79. Here we have 3.7, 3.7, 9 is here. So that one is 0.5786, 0.5786, 0.5786. So that is the logarithms for 3.79. What is the logarithm of 10 raised to power 2? Just take the power and add to this number. The power. Look at this one. It was 10 raised to power 1. We added 1 here. This is 10 raised to power 2. You need to add 2 here. Therefore, the whole thing is 2.5786, and that is the logarithm of this. So if you take your calculator, for example, and press directly the logarithm of 379, you delete this, log 379. The answer is what? 2.5786. the one we have from the table. Now what if it's a very big number like this? 52 8000 0 1 2 3 4 5 6. Yes, so this number will never be available in the table. What do? Write it in standard form. We start here 1 2 3 4 5 6. So our number is 5.28 times 10 raised to power 6. Now find this number from the table. Is it there? 5.28. So 5.28 is available. 5.2 and then 8. Right? That one now is 7226. So it's 0.7226. Now here it is 10 raised to power 6. It means you take the power and then add it here, so plus 6. So that one is, why do I take it? Because log 2 base 10, this is 1 million, 10 raised to power 6 equal to 6. So this is 1 million instead of writing 1 million here. So the power is what we add. So the answer here is 6.7226. So if you take your calculator and place log 52. So the logarithm, the log base 10 of 52.80,000 equal to 6.7226. So this is the logarithm of this number. Now, as you can see, this logarithm has two parts. There is this part of the whole number, and there is this part of which contains the decimal part. Now, the part that is the whole number, we call it the characteristic. And the part that has the decimal point, this one is 0.7226, is called the mantissa. So 6, in this the logarithm, the log has two parts. Number one is called the characteristic. Characteristic is the whole number. The whole number here is 6, therefore 6 is a characteristic, right? The second part of a logarithm number, of a log, is called the mantissa. Called the mantissa. The mantissa is the decimal part. The decimal part. So from here, 0.722 is called the mantissa. Therefore, this one is the characteristic, and 0.7226 is the mantissa. It is very important for you to know the parts of a logarithm. Now, what about numbers? How do we get the logarithms of numbers which are less than 1? For example, 0.034. How can you get the log of this? So, for example, find the log 0.034. How do you get a log of a number that is less than 1? Because our logarithm table provides logarithms of numbers from 1 to 9.9. Similar way, you have to write this number in standard form. So let us write this number in standard form. 0.034, the standard form is, so the decimal point is here, so we go to the right, 1, 2. So we will have 3.4 times 10 raised to power negative 2. Right? Now, the power here, base 10, the power here is what is called the characteristic. What we are going to obtain the logarithm of this is the mantissa. Very good. So let us get the log of 3.4. The log of 3.4 is 0.5315. What about this one? The logarithm of 10 to the power negative 2 is you take the power. The power is what we call the characteristics, the negative. So now from there we have the sum of log to base 10 negative 2. The answer is negative 2, the power. So we need now to add. Now we add the character. This one is called the characteristic, and this one is the mantissa. You add them. So it is negative 2 plus 0.5315. Now in this case, you don't add like negative 2. This one is called negative, but here we call it per 2. It is called per 2. We usually write it like this, per 2, right? 5315. So you don't add like you can add negative 2 plus a number. No, it is called per, and it is a characteristic. Therefore, it is per 2.5. So it is per 2.000 plus 0.5315, and that one is gives you per 2.5315. So that's how you do it. So this is the logarithm of this number that is less than 1. The negative is called per. We call it per 1, per 2, per 3. So negative we call it per 3, per 1, per 4, all that. This part is the characteristic, and the second part is the mantissa. Characteristic, and the second part 0.5315 is the mantissa. It is important for you to note that. You can do more examples and find it out. Find the log of 0.0063. Rule number 1, write this number in standard form. 6.3 times 10 raised to power, the point is here 1, 2, 3, negative 3. When you go to the right, the power is negative. Now we get the logarithm of each of them. So now we are looking for log 6.3 times 10 raised to power negative 3. But we know now log 6.3 can be read from the mathematical table directly, which will give us 0.7993. The log 10 raised to power negative 3, the answer is negative 3. You take the power, right? Now, we have now the two parts of our logarithm. We have the first part, the whole number, and then the decimal part of it, the characteristics. So now you combine them, and this one is written as per 3, then you add 7993, and that is the logarithm of 0.063. This number is read as per 3.7993, per 3 point. Now we want to look at the anti-logarithms. We have been looking for logarithms. Now we are looking at anti-logarithms. Anti-logarithms is the reverse of finding the logarithm of a number. Now if we have the logarithm, we can find the number whose logarithm we have. Yes, if I have a logarithm of a number like this, I can go the reverse and find this number 0.06 like that. So let us look at this example. Find the number whose log is per 2.3031, right? So we want to look for the number whose logarithm is this. So we don't know the number, so we can say, so the first thing you need to understand, this one is the characteristics and this is the mantissa. Simply just take this one. This one means it is 10 raised to power negative 2. We are done with the mantissa, the characteristics, sorry. Now we go to the table of anti-logarithms and find the number of 0. What is remaining here now is, after removing the per 2, which I have used here, what is remaining is 0.33031. You go to the table of AND logarithms. This is the table of AND logarithms to base 10. This is the table for AND logarithms. So you find, I want the AND logarithm of 0.3031. So you come here, 0.30 is here, and then the next number was 0.03, and then 3. 1, 2, 3, 3 is here. So my number is 2.001. Is 2.009. You move across to where we have 1. The 1 is 0. Therefore, our number is 2.009. 2.009. Now this 2.009, this is you can round or leave it like that. So what does this mean? This means it is 1 over 100 times 2.009. This is the same as 0.002009, and that is the number whose AND logarithm is this. This is the number whose AND logarithm is this. So the AND logarithms is the reverse, is rooting for the number whose log you have. So if you have a logarithm, you can find the number for which the logarithm you have. Now we want to look at the application of logarithms in mathematics. So you will be asked, if you are given a sum like this and you evaluate this using logarithms. So you must remember the rules of indices. If it is multiplication, you should add the logarithms. The logarithms, remember, logarithm is the same as the power. If it is division, where we have division, this line means division, you must divide. When you are dividing, you should remember, when I divide logarithms or indices, what do? I subtract. So this is how you go about this one. You write number, you draw a line, and then you write standard form. And then finally you write the log. Like this. My first number is 415.2. This number, I don't have it, I must write it in standard form. So we have 4.152 times 10 raised to power 1 to power 2, right? So that is my first number. So you find the logarithm of 4.152, right? And then from here, 10 raised to power 2, the log here is the power. So our characteristics is 2. You write 2 in the logarithm column. Then you look for the mantissa for this number. Find the logarithm of this number and it will give you the mantissa now. So log 4.152 will give you 6182. The next number is 0.0761. Write the number in standard form, which is 7.61 times 10 raised to power 1 to negative 2. So my characteristics is per 2. Find the logarithm of this and it will, you add here. The logarithm of 7.61 is 8814. But remember, this number and this number has been multiplied. So these are the powers of them, the logarithms. So what do? We add them. And then we draw a line here to show that we have finished doing the numerator. So you add. 2 plus 4 is 8. Is 6. 2 plus 4 is 6. This is 7. This is 9. This is 14. 4 carry 1. Right? So here it is 2 plus 1, the one you carried here, that is 3. 3 plus minus 2. Remember, part 2 is a negative number. right? So 2, that is 3. 2 plus 1, the one I carried from here, 3. 3 plus negative 2 is like this. So it is like 3 minus 2. The answer is 1. So here is 1. So you underline like that. The denominator is now, the number for the denominator is 135. Write the number in standard form, 1.35 times 10 raised to power 1, 2. So our character here is 2. Find the mantissa or the logarithm of 1.35, which will give us the mantissa. And that one is 1303, right? Now, because it is only this number, what we are going to do, this number and this one, because it is a division, we are going to subtract this one and this one, we are going to subtract. The answer of the numerator and the answer of the denominator, we subtract them because it is a division. So when you subtract, that is 3, 7, 6, 3, and this is 1 minus 2. 1 minus 2, the answer is negative 1. Therefore, we call it power 1. We call it power 1. Oh, this was 9. Eh? I have seen here. This is 6, this plus this is 9. Not that, that is 9. And then... so here is 9. This one is 9. And 36, 9. Thank you. Now, once we are here, we are finished. But we must get the number. So we go back. And this is now what we call the anthrog. Once we are here, we find the anthrog of this number. The first thing, we know the characteristics 1. So it is 10 raised to power negative 1. We are finished with the characteristics times. You go to the anthrog tab and find the anthrog of 0.3693, and that one will give you 2.341. So this is the standard form, and then you multiply this one, it gives you 0.2341, and that is the number. Therefore, the answer here is 0.2341. The answer for this one is that you must use a logarithm like that. I want to do another one. In logarithm, when we have this number like this and you have been asked to use logarithms to evaluate the square root, you should always remember that, and the cube root. But this number can also be written as this. This number, sometimes they can confuse you and write like this, that 9.51 times 725 divided by 0.758 raised to power 1 over 3. So a number raised to power 1 over 3 is the same as the cube root. I talked about that. And this one means this number raised to power a half. A half is the square root of a number. If it is a fourth root, you will find here it is 4. So you should always remember that.